The next lesson in Chapter 1 is Lesson 1.2, Evaluate and Simplify Algebraic Expressions. Please write the definition down of an expression. Any grouping of numbers, variables, and operators. The key thing to recognize an expression is that it's missing an equal sign. Here's more terminology on the right. The definition for power. A power consists of an exponent and a base. The exponent represents the number of times the base is used as a factor. For example, we talked about this on our review worksheet. If we have x times x, that equals x squared. For our terminology, x represents the base. That's an arrow. The 2 is the exponent. So we're raising it to a power of 2. Other ways we can write this, if we include a number and a variable, such as 5m times 5m times 5m, that would be the same as 5 and m to the third power, meaning your base is 5m and the exponent is 3. By definition, a variable is simply a letter that's used to represent an unknown value. A term is any part of an expression separated by addition or subtraction. Coefficient is a number followed by a variable. For example, if you have a term called 4x squared, the 4, that number in front, is the coefficient. I defined constant on the review worksheet. It's the value that doesn't change. The key thing with a constant is it does not include a variable. It's usually the number at the end of an expression. Using the definitions above, circle the variables, box the constants, and underline the coefficients. Do that for each example and then press play, and we'll look through the results together. Taking a look at my first example, x to the 5th is circled, x to the 4th is circled, and the product xy is circled. Those all represent variables. Notice I boxed the negative 100, not just 100, as my constant. Now the only thing technically that I underlined in that first example was 15. That is the coefficient in front of the xy term. But technically there are other coefficients represented. The number in front of x to the 5th, I'm just going to move this over here, is technically a 1. And the number, you believe this, in front of x to the 4th is technically negative 1. Those coefficients will be meaningful when we evaluate. In the second example, we kind of run into that again. We have x to the 3rd and y squared this time. Those are both variables. Again, that negative 8 represents the constant. I've underlined the 3, but we also have to recognize that in front of the y squared, technically there's a 1. Recognizing those terms will be helpful when we evaluate. So, speaking of evaluate, let's take a look at order of operations on the left. Understanding order of operations is very essential when we evaluate expressions and simplify. PEMDAS, P-E-M-D-A-S, is a mnemonic way to remember these terms. Parentheses, exponents, multiply then divide, add then subtract. If you know your order of operations, you'll be in great shape to evaluate the expressions on the right. Well, technically, we're only evaluating one expression. It says, evaluate the expression when x equals negative 3. This means wherever we see our variable, we're going to substitute in negative 3. Now you're going to probably guess by now we're working with a lot of negatives and we may even see some fractions here and there. If we substitute in negative 3 directly to x, our expression will look like this. Negative 4 times negative 3 squared minus 6 times negative 3 plus 11. We have to be very careful with our order of operations. In that first term, negative 4 times negative 3 squared, Order of operations would indicate we're going to square -3 first, which means we multiply -3 by itself. When we do that, we get +9. Keep that -4 on the outside, and now we have +9 on the inside. For that second expression, we have -6 times -3. So I'm just kind of working from left to right on this. Here we're multiplying two negatives together. That's going to change our sign to +18. And then we've got that +11. Now what we have left is multiplying. -4 times 9 is -36. If we add 18 to that, and then add 11 more, we end up with -7 as our end result. This is the kind of work I would look for on the non-calculated portion of any assessment. Before we look at combining like terms on the left, I want to look at all the different ways negatives can impact your answer when we simplify. Notice all of these have a 4 or -4 as a base, and the powers go anywhere, or the exponents go anywhere from 2 to 3, but that's going to have an impact on our final answer. 4 squared just means 4 times 4. That's +16. Hopefully that made sense without too much kind of thought through it. The second answer is a little trickier though. The negative out in front doesn't get the squared because it isn't in a parenthesis. Technically what this means is it's -1 times your base of 4 being squared. 4 squared then, order of operations, is 16. This makes our answer -16. That's going to be tricky to remember. And then the difference between that example and the next one, now the parenthesis is being squared, so you're squaring -4, you're multiplying it by itself 2 times, that goes back to +16. It's a lot to think about. And when you raise your exponent even higher, that'll make a difference as well. 4 to the third power, 4 times 4 times 4, is +64. -4 to the third power, again, is kind of like our second example. That negative on the outside just means your end result is going to be multiplied by -1. We've already talked about 4 to the third power is 64, but that negative out in front makes it -64. And last but not least, if -4 is even in the parentheses, but you're raising it to the third power, that just means -4 times -4 times -4. We have 3 overall negatives, which means our product is going to be negative as well. Order of operations, evaluating these expressions, is something that we will do throughout the year. Our last definition on that left-hand side, combining like terms. We simply want to add or subtract coefficients of like terms in order to combine them. Let's test that out on the right. When combining like terms, you have to recognize the variable is identical in order to combine those coefficients out in front. For example, 5p squared plus 1p minus 2p squared. The variable is the same, but the exponent changes the term. Recognizing that if you have a p to the second power here, that only combines with other variables that are the exact same. And then we look at those coefficients out in front. 5 minus 2 is just 3. This condenses to 3p squared plus 1p, or you can just write the variable itself, and that would indicate that its coefficient is automatically 1. Now, sometimes like terms are embedded in a parenthesis. Therefore, order of operations comes into play. Over on the right, we have 3 times y plus 2 minus 4 times y minus 7. Here, we need to eliminate the parentheses by applying the distributive property, which we talked about in lesson 1.1. 3 times y plus 3 times 2 would be 3y plus 6. The second part, we have to be careful with that negative again. Distribute the -4 into both of those terms in the parenthesis, and that would give us -4y plus 28. Because -4 times -7 would be positive 28. And now when we combine our like terms, we have two terms with a y variable. 3 minus 4 is -1 or -y. And then 6 plus 28, our constant, is 34. All right, you try the last one. Can you get rid of the parenthesis by applying the distributive property and combining like terms? Pause the video and then press play when you're done. Did you come up with negative 2p to the third power plus 4p minus 1? If so, then you've combined like terms properly. If not, take a look at the step I did in the middle to see if you can find where things went in a different direction. When you're ready, flip it over to the back. You know a lesson won't be complete without some application, creating those verbal models. Being able to read through this word problem, create an expression, and evaluate for a certain variable. The tips on the left-hand side identify your keywords and recognize what your variable stands for. Let's try that out. You're selling homemade candles at a craft fair for $13 each. You spend $450 to rent the booth and buy materials for the candles. Write an expression that shows your profit from selling what happened there? Hang on. Your profit from selling C number of candles. C is our variable. Now, if you look at the word problem, let's recognize some of our key information. It says we're going to make $13 per candle. So that $13 is going to help us determine our profit. If candles sell for $13 each, that means 13 times C is how much money we would make at the fair for selling our candles. But then we have to think about what it costs to rent the booth and then pay for materials, because that's going to negate our profit, which means we have to spend that initially, so we have to kind of make that up before we earn additional money. That $450 for rent means we have to subtract that from the money we made selling candles. So utilizing that with that 13C, if we recognize this is the amount of money from selling candles and we subtract $450, although I don't know why it's doing that. It just there we go. It just moved for no reason. Sorry. 13C minus 450 is an expression that helps us determine how much profit we would make depending on the number of candles sold. Obviously, the more candles, the more C we have as a value, the higher our profit would be. Last but not least, this is where a calculator would likely be helpful. Find your profit if you sell 75 candles. In our expression above, that means C equals 75. Substitute that into our expression, 13 times 75 minus 450. Once you have that written down, type that all into your calculator at once. 13 times 75 minus 450, you should get a value of $525. That means you would make a profit of $525 at your craft fair if you sell 75 candles. Not too bad. Nice work. We're going to save our last example for the next time we meet in class, and we'll do that problem together. You are done with your notes for 1.2 for today.